Hi, welcome to the Change Elements API session, the easy way to compare changes. My name is Diego Piñate, a software engineer at Bentley Systems working on the iTwin platform. On this session, we will talk about what change is, how the Change Elements API can help you visualize change on viewer applications, we will see a demo of the API in action, and where to learn more. By understanding changes that occur to an iModel, we can empower viewer applications to visualize said change. The Change Elements API has been used by Bentley internal applications for about 4 years now to build change visualizations. Now, it has been made public to be used with the iTwin platform. The goal of the API is to provide summaries of changes between versions and to empower the visualization and inspection of change. Let's start with a primer about change. When you have an iModel, it has a state. In this example, we have version 1 of the iModel to the left, and it contains two elements, A and B. A connector or an editing application can look at that iModel, do some work on it, and generate what we call a change set. A change set simply contains all the modifications that occur to the iModel. If we apply the change set, we can generate a new version of the iModel that has a new state. In this example, A was deleted, B was modified in some way, and C was added. So our new version would look like something to the image to the right. When you use an iTwin Viewer application, you can visualize what's contained in the iModel on a specific version. However, the viewer has no sense of what has changed, as it only looks at the iModel in that point in time. So in our example here, both viewers don't know anything about what happened to the iModel, just what's currently in it. So how could a viewer understand change? That's where the Change Elements API comes into play. The viewer can ask the API what has happened between a range of versions and get a summary of what has changed. In our sample here, the viewer asks the API what happened between versions 1 and 2, and it replies with a summary of changes that we call a comparison. Now that the viewer has the comparison, it can decide what to do with that summary. We could highlight the changes in the view, add a list of what changed, allow the user to inspect which properties have changed, etc. In this little example, the viewer colorizes B as blue to represent a modification, and C as green to represent that it is a brand new element. The colors can be anything really. That depends on the implementation of the viewer, but for our examples and demos, we will use red for deletions, blue for modifications, and green for insertions. Let's see how one of our internal Bentley apps, Project-Wise Design Review, leverages the API. This application uses iTwin technology to allow users to review their design files, visualize them, create issues, and many other features. But with the use of the Change Elements API, it can also find all change elements between two versions. In this screenshot, we have a list on the left that provides all change elements in the current model. One of them have been turned off in visibility, while the other two are displayed and highlighted in the screen. The app allows you to also isolate them to only see what has changed, like in the picture on the top right of the slide. The app also allows the user to see a side-by-side view by opening both iModel versions and retrieving information and graphics on both. In this case, the Change Elements API has found that the element in question has changed its geometry, volume, and positioning. From the two views, you can notice that nozzles were added to the current version. It's also noticeable that the motor diameter has changed, both in the views and in the properties of the elements, as we can see in the table. Now that we have covered what changes are and how a viewer may benefit from inspecting them, let's talk about the API. The Change Elements API is a REST API that can be used to do two different operations. You can enable or disable change tracking for your iModels, and you can request a comparison summary of what has changed between two change sets or 2 points in time. So let's take a closer look at each of these operations, starting with tracking. For the API to be aware that it needs to generate reports for your iModel, we need to enable tracking on the iModel. That means that whenever you create a new name version of your iModel, for a given chain set, the API will start a backend process that will go through the changes and generate a summary. This will happen anytime a new name version is created using the iModels API. After that, we're ready to query for comparison summaries. But how do you enable tracking? Well, it's as simple as doing an HTTP POT request. The payload body contains the iModel ID, iTwin ID or project ID, and the value of the enable flag. Once we execute the request, the API will start listening to new name version events and process them when they occur. After we have enabled tracking, name versions were created, and the processing is done, we can now query for a comparison. To get a comparison, we use an HTTP GET request. The query parameters of the request contains all the information the API needs to generate the report, like which iModel to get the report for, and the range of chain sets to use for the report. Once the request resolves, the response will contain a JSON object with multiple arrays. Each element that has changed is specified by a single index in all arrays. By going through each array, you can inspect all elements on the iModel that had changes between the queried versions. So let's take a closer look at what these values mean. The elements array contains all the IDs of the elements that have changed. These IDs can be used to query the iModel for more information about them. The class IDs array contains the IDs of the EC class of the corresponding element. These are useful to query properties of the elements. The opcodes array contains the operation done to the element. This can have 3 different values as shown in the table here, but simply 9 means that the element was deleted, 18 means that the element got inserted, and 23 means that the element has been modified in some way. You can read more about operation codes in the link below. The model IDs array contains the models that change element resides in. The type array contains the type of operations that occurred on the element when it is modified. This value is a number which can be thought about as bit flags. Each bit represents a specific type of change. For example, 1 means that a property has changed. 2, which is binary 1, 0, means that the geometry of the element changed. 4, binary 1, 0, 0, means that the element's volume or position has changed. 8, binary 1, 0, 0, 0, means that the element was affected indirectly by another element. And this simply means that the element has other related elements that provides properties for it, and those elements had changes. Finally, 16, binary 1, 0, 0, 0, 0, means that some internal metadata has changed on the element. This last one is not important for visualization. Moving on, we have the properties array, which contains all the properties that have changed in the element. This array contains specifically the property accessor strings that can be used to query the value of the properties on the iModel for the element. The new checksums and old checksums arrays contains the checksums of the values of the properties. This is very useful to determine if a real change occurred or if a value was simply flipped back and forth between versions. The parent IDs and parent class IDs contain information about parent elements of the change element. If they're 0, it means the element simply has no parents in the current version. With all this new knowledge, we can now interpret the same example and understand what has changed in the iModel. We have a single element that changed, given that arrays only contain 1 item. The element ID is shown in the elements array. We know that the element was modified due to the opcode or operation code that is given in the opcodes array. We can see that the element has a property change because of the type value. We can also see that the property user label was the property that got changed. Finally, we know that this element has no parent elements because the values for parent ID and class ID are 0. Here's another example with different types of change. We have a single element that changed, given that arrays only contain 1 item again. We know that the element was modified due to the opcode. We can see that this element has more changes than just properties. In this case, we have the number 7, which is binary 1, 1, 1, which means that properties, geometry, and placement have changed in the element. We can see that the property motor diameter got changed. And we can see that this element does have a parent this time, with the given element IDs and class IDs as shown in the last arrays of the JSON object. Now that we understand how the API works and how to read the comparison summary, let's explore visualizing change using the iTwin platform Sandbox environment. This is the Change Element Sandbox sample. Links will be provided at the end of the session for you to use this yourself. Let's take a closer look at what it can do. You can select the version of the iModel using this drop-down here. Once you do this, we're requesting a comparison from the Change Elements API. And after that happens, we highlight everything in the view. But before we go into details about how the viewer works, I want to show you how a comparison result actually looks like from the sample by looking at the Networks tab here. If we take a look, we can see that we have all the arrays that we speak of. We have the elements array that contains all the element IDs. We have the properties array, which are empty for some elements, and they will be empty arrays for any element that do not contain any property changes. We have the different types of change, and as you can see, there are different numbers based on the bit flags as we spoke, and we have operation codes for each of these elements. Now, after we query that information, we can use that data in the viewer to visualize the change. Now, we have added certain functionality to the sample to have the ability to turn on and off certain things like updated elements, inserted elements, and unchanged elements. So you can use the toggles here to turn on and off the type of changes that you want. If you only want to see updates, you can do so like this. Now, you may be wondering, what about deleted elements, and why don't we have a toggle in the for deleted elements in this particular sample? Well, the reason is that deleted elements, the graphics for deleted elements do not exist in the current version of the iModel, as they got deleted. So what you have to do is you would have to open the other iModel and get the graphics from them. That was out of the scope for this particular sample, but we do just that in our project-wise design review application. So it's definitely doable. It's just not something that we wanted to cover with this particular sample. So as you can see, we can control the visibility and we can explore the changes that occur to the iModel. So let's talk a little bit about how this is done and how the sample is set up so that you can explore it a little bit more on your free time. There are all the functionality is contained in these files here to the left. And the main file that starts the viewer is this change elements app.tsx file. It simply contains boilerplate code to start a viewer application. We then have the change elements widget file over here, which contains all the functionality and the UI for this React panel down here, where we can have the toggles and has all that functionality. We also have the change elements client file. This actually has the functionality to actually do the query to the API. And you can take a look at how that's done over here. And as you can see, we're simply using the API URL, forming it properly with those query parameters that we spoke of, iModel ID, iTwin ID, the change sets that you want, and then it will fetch the results and properly type them. Now, the last file that we have, it's called Change Elements API, and it provides with what we call a future override provider. Not to go into much detail, but what these allow you to do is that you can add a future override provider to your viewport. And you can then tell the viewport how do you want to colorize or show the elements or not show them that you care for. So in our case, we're using the results of the Change Elements API to generate and colorize the updates and inserted elements and have the unchanged elements appear as translucent like this. So this is mostly all that's here in the sample. I encourage you to explore it on your own free time. It contains some information and you can mess with the code in real time and really explore what using the API can give you. And I really encourage that. So now let's go back to the presentation. To summarize, we looked at an overview of what change is, how the API works, how to interpret comparison summaries, and how we can leverage the API to visualize change. Here are some useful links I really encourage you to experiment with the sample Sandbox viewer, as it will allow you to explore the usage of the API in an iTwin viewer application straight from your browser. It will even allow you to make code changes to test things out. Thank you for tuning into this session, and I hope that you will be able to explore change on your own time. Don't hesitate to contact me with questions at the email shown in the slides, and I hope that you have a great day.